Okay, final short video for Chemistry Paper 1 that applies to both foundation and higher tiers. Is about electrolysis and how we use electrolysis to extract reactive metals. So remember what electrolysis is. Electrolysis means splitting up a compound using electricity. Those compounds have to be ionic compounds, which means they consist of a metal bonded to a non-metal. An example of an ionic substance is shown here, which is zinc chloride, ZnCl2. Notice that the formula you can work out by looking at the ions, which are shown here, and because the zinc is 2+, I need to have two 1- chloride ions to cancel out the charge, and so the formula shows that you need 2 chloride ions for every 1 zinc ion. So the formula is ZnCl2. Notice that it's got the word molten here, and that's essential that we can only do electrolysis if we've got a liquid. So that means I've either melted my ionic compound, it's been melted, it is molten, or I've dissolved my compound in a solvent like water. Okay, in this case the electrolysis is molten zinc chloride. So the scientist had taken zinc chloride, heated it up until it's liquid, and now we can explain what happens because the ions can move. So why do we need a liquid? So that the ions can move and carry the charge and create an electrical current that's going to complete this circuit. During electrolysis, we've got two electrodes, a negative one and a positive one. Opposites attract, so the negative chloride ions are attracted to the positive electrode. The negative chloride ions will go to the positive electrode, and the zinc ions, which are positive, will be attracted to the negative electrode. So the products of this electrolysis will be zinc forming at the negative electrode and chlorine gas forming at the positive electrode. This electrode will be covered in bubbles of pale green smelly chlorine, so like swimming pools, and it's going to be hot in here, so zinc is going to be forming and probably being melted. Liquid zinc will be forming at the negative electrode. Okay? This time we're applying what we know about electrolysis to the extraction of aluminium, but you know that any metal that is more reactive than carbon will have to be extracted by electrolysis. Okay? Aluminium extraction is slightly special because we've got a solvent called cryolite, into which the aluminium oxide is dissolved. So again, the ions can move because the aluminium oxide has been dissolved into this stuff called molten cryolite. Again, we've got a negative electrode and a positive electrode. Make sure you remember that these electrodes are made out of graphite, which is a form of carbon. And what's happening is exactly the same as our last example. The aluminium will be attracted to the negative electrode, so this will be a little puddle of liquid aluminium, and the oxygen will be attracted to the positive electrode, where it will make bubbles of oxygen gas. Now we could go a little bit further here. You can imagine the oxygen gas is forming on this carbon electrode, and everything is really hot here, so actually there's a little side reaction where the carbon from the positive electrode is going to react with the oxygen and become carbon dioxide, which will be going off into the atmosphere of this industrial process wherever it's happening. This means that the graphite, the carbon electrode, will be used up and it will have to be replaced regularly. Higher tier people, at these electrodes, at the negative electrode, positive ions gain electrons and become atoms of the metal again. Whereas at the positive electrode, oxide ions will get rid of their electrons and become oxygen molecules. So we need 2 oxide ions to make 1 oxygen molecule, and that means that a total of 4 electrons have to be got rid of. Higher tier people, remember that gaining electrons is reduction. Reduction is gain of electrons, and the opposite of reduction is oxidation. Oxidation is loss of electrons. OIL. Oil, oxidation is loss. RIG. Reduction is gain. Oil rig. Okay. In this example here, you could say that the aluminium oxide is being reduced because the oxygen has been taken away. So that's our other definition of oxidation and reduction. Reduction can mean taking away oxygen, or reduction can mean gaining electrons. And oxidation is the opposite. Oxidation can mean adding oxygen to something. This carbon here is being oxidized to carbon dioxide, and oxidation is also loss of electrons.